Okay, this is Mr. Anderson for Kellogg Community College, and I'm going to be going over the last part of the Chapter 7 test review. We are looking at the last section of the book, Section 7.8, and a couple problems from that to get us used to imaginary numbers. All our answers have to be in A plus BI format, so I will make sure at the end of these problems to make sure that's true. And we have to get rid of these square root of negative 1s, which are going to be equivalent to the imaginary number I. So what we do with a problem like this, which we couldn't type into the calculator, so we are going to break this into the square root of 9 times the square root of negative 1. What this makes is the square root of 9, which is 3, the square root of negative 1, which is I. And there's my answer. Now what I have here is the square root of negative 12. I'm going to break that into 12 and negative 1. The square root of 12 can be further broken down because my x squared root chart would be 1, 4, 9, and 4 can divide 12, so this is the square root of 4 times the square root of 3. 4 times 3 makes 12, and the square root of negative 1 is I. The square root of 4 can be broken down into 2, and 2 square root of 3i is the answer. Looking at problem number 53, what we have to do is, since we're subtracting these two items, make sure we distribute the negative, since that is going to then become minus 2 minus 4i. And so we go 8 minus 2, which is 6, and 7 minus 4 is positive 3i. And there's the format of a plus bi, a plus bi. Same thing goes here. We're going to distribute this negative, so this becomes positive 7, and this becomes negative i. So we're going to have negative 2 plus 7. Negative 2 plus 7 is going to be positive 5. And then we're going to have 6 minus I, so that's going to be, or minus 1i, is going to be plus 5i. And the format is a plus bi, so we do not need to factor out a 5 in this situation. That is the finished answer. Now, in the next two problems, we're going to do a little bit of FOIL. And the FOIL is going to be very important because we're going to kind of use that for problems 57 and 58. In this problem here, what we will do is we will do some FOIL. We will rock out this cable here. Negative 4 times 3 is negative 12. Negative 4 times negative 4i is positive 16i. 5 and 3 makes a positive 15i. And then what we'll do is go 5 times negative 4, and that 5i times negative 4i is negative 20i squared. Now that's important to see because you've got 5 times negative 4 is negative 20, I times I is I squared. So let's do some simplification. I got negative 12. This is going to make a total of 31i. Now this is negative 20, and that I squared is going to be negative 1. And the reason for that, if let me just get that here. If I is equal to the square root of negative 1, then I squared is technically the square root of negative 1 squared, which is the same thing as negative 1. So that makes negative 12 plus 31i plus 20, because negative 1 times 20 is positive 20. We're going to move this to the front because the format is a plus bi, so we need the 20 over here. Negative 12 and 20 make a total of 8, because 20 minus 12 is 8, plus 3i, or 31i. So this is a plus bi format. So anytime you see I squared, it turns into negative 1. And now we have the key to problems 57 and 58. This is going to be kind of a two problems where they look the same except for this middle term is a plus and a minus. So this gives me negative 16. This here gives me positive 20i. This gives me negative 20i. And this gives me negative 25i squared. Which means that these two simplify to 0, so I got negative 16 minus 25. I squared is negative 1 always, so this is negative 16 plus 25, since we have negative times a negative is positive, and so my answer is, oh wait, shoot, I'm sorry, negative 4 is positive 16. I'm gonna have to fix that. And then the positive 16 and 25 makes 41. 41. So sorry, negative times negative is positive. All right. Now, you'll notice that this answer to the problem of 56, you see that you actually don't have, you do not have any i's left in the problem. So when we have to get I out of the denominator, because the I is the same thing as the square root of negative 1, we technically can't have an answer with an I in the denominator. So we'll multiply the top and bottom by 1, and that 1 will be the binomial, creating a FOIL problem of 5 minus I instead of the 5 plus I. Alright, so my numerator, if I distribute that, is going to be 5 times 26, which is 130, minus 26I. Now that's the proper format for the numerator, a plus bi. So our denominator, if we FOIL this out, this becomes 25, then it becomes negative 5i, then positive 5i, which will simplify to 0. And then the I times negative I is negative I squared. So those two go away, which is kind of nice. And this is going to be 25 minus negative 1, which makes this 24. Cool. So my answer is 24 here. Now, what I should highlight is that sometimes these denominators can get simplified quite a bit. In fact, since this is a monomial, what might be nice, since we have to get this into a plus bi format, let's just break this down into 130 divided by 24 minus 26i divided by 24. 130 divided by 24, that actually works out to pretty darn good. 130 divided by 20. Oh, it should be 26. Oh man, I messed up there. So make sure that's swipe. 26. This is going to be 26. This is going to be 26. And this is going to be 26. So 130 divided by 26 is 5. And 26 divided by 26 is 1. And so there we go. 5 minus I is your answer. Sorry about that. This is my second mistake this video. Again, the first mistake up here, this is positive 16. And this right here should be positive 1, 26. So, whoops, sorry about that. All right, now here we're going to do the same thing. We're going to multiply this by a fancy 1, or this binomial 4 minus 2i. 4 minus 2i. And so this numerator gets distributed here. So this is 12i minus 6i squared all over. Do some FOIL here. This is going to be 16. This is going to be negative 8i. Do the inside cable, positive 8i. And then we do the last cable here, negative 4i squared. Now my numerator here is going to become 12i minus 6 times negative 1. And my denominator is, these are going to simplify. It's going to be 16 minus 4 times negative 1. Now my numerator, this is going to become a positive 6. So my 6 has to go in front, plus 12i. And my denominator is going to be 16 plus 4. So that becomes 20. Now because we have to fit the format a plus bi, we're going to split this up into 6/20ths. And let's make sure that I've got everything right here. 6/20ths plus 12i over 20ths. And that 6/20ths will simplify down to 3/5. And the 12/20ths, 3/10ths. Gosh darn it. There we go. And then the 12/20ths breaks down to 3/5 I. Alright, now let's go to the bottom problems here. I have a little trick for these ones here. These ones are kind of fun and fascinating because the trick for these is that you should set this up like I is equal to I. So I to the first power is I. Now I to the second power is equal to negative the I to the second power is negative 1, no square root. I to the third power is these two multiplied together, so I to the third power is negative I, and I to the fourth power is 2 negative 1, so negative 1 times negative 1, which is positive 1. Now, if I'm doing I to the fifth power, all I need to do is kind of go up to this chart and go 1, 2, 3, 4, 5. So I to the fifth is I. I squared is already negative 1. I to the 7th. 1, 2, 3, 4, 5, 6, 7. I to the 7th is negative I. Now, the pattern here works because when you get to the 4th power, that's just equal to 1. So I to the 7th is the same thing as I to the 4th, which is 1, times I cubed. So it really becomes I cubed. So I to the 4th is 1 because of this. But when we get to the 32, it just takes some careful counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you see that every time we land on the 4, it's a multiple of 4. So I bet we're going to land here with I to the 32nd power. All right, so here we go. 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there you go. I to the 32nd power is 1. Or I to the 4th, sorry about that, I to the 4th raised to the 8th power. 8 times 4 is 32. Or 1 to the 8th power is 1. 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or I to the 12th, which is 1 times 1 times 1, times I cubed. So negative I. Now it's good to memorize this little pattern here. It works out pretty nicely. I to the 42, is it a multiple of 4? Well, it isn't. But I to the 40 is, and I to the 40th power is the same thing as 1. And that also leaves I to the 40th plus I squared. So this is 42 right there, so I squared is negative 1. Now let's go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is I. And so that's how that works. Or, if you want to look at it this way, it's I to the 4th, I to the 4th, and I. Or 4 plus 4 plus 1, which is 9. All right, there you go. There's my answer. Sorry about making the mistake in the earlier parts there. I'm glad I fixed those before I left the problems. So thank you very much for watching.